When we subtract, we tend to think of it as taking away. If we illustrate our subtraction out on a chipboard, we can have negative chips to help us visualize taking away negatives. Our black chips are going to represent positive values, and our red chips are going to represent negative values. Let's start by illustrating out subtraction problems using positive values. We want to start out by illustrating positive 7 minus positive 3. So we start out with 7 positive chips on our board. To subtract positive 3, I simply take away 3 black chips, and that leaves me with 4 black chips. So positive 7 minus positive 3 leaves me with positive 4. But what if I want to go the other way? What if I want to do positive 3 minus positive 7? A lot of us, when we were learning to subtract, learned that bigger value had to come first because otherwise there isn't enough to take away. And we can see here we only have 3 chips and we need to take away 7. This is where zero pairs are going to come in. If I combine a red chip with a black chip, or a negative 1 with a positive 1, they have a combined value of 0. This means my board still has a value of positive 3. So if I need to take away 7 chips, I have 3 black ones to start with. I can add 1 zero pair, 2 zero pairs, 3 zero pairs, and 4 zero pairs. Now my board has a value of positive 3, but I also have 7 black chips that I can now take away. When I take away my 7 black chips, I can see that I'm left with 4 red chips. So positive 3 minus positive 7 leaves me with a value of negative 4. When we set up a problem using all negatives, we see it looks very similar on our chipboard. If I want to subtract negative 7 minus negative 3, I'm going to start out with 7 red chips on my board. I can then take away 3 of my negative chips, and that leaves me with 4 red chips on my board, or negative 4. If I wanted to go the other way and subtract negative 3 minus negative 7, I run into the same problem. There's only 3 red chips on my board, and I need to take away 7 of them. So again, we can add enough zero pairs to our board to keep the value at negative 3, but also give us enough red chips to be able to take away 7 of them. Now my board has a value of negative 3, and I have 7 red chips that I can now take away. When I take away my 7 red chips, I'm left with my 4 black chips. So negative 3 minus negative 7 is going to leave me with a value of positive 4. But what happens when we start mixing positive and negatives in the same value? What if I want to do positive 7 minus negative 3? We can see our board starts with 7 positive chips on it, but I don't have any red negative chips to take away. This is where we again have to come back to our zero pairs. If I add 3 zero pairs to the board, this accomplishes 2 things. First off, our zero pairs we know have a value of 0, so our board is still worth positive 7. Secondly, it now gives me 3 negative values that I can take away. So I'm going to take away my 3 negatives. And when I do, I'm left with 10 positives. So positive 7 minus negative 3 leaves me with positive 10. What if I want to reverse that problem? What if I wanted to instead do negative 3 minus positive 7? Well, we can start with our 3 negative chips on the board. We are a long way from having 7 positive chips to take away, so that means we're going to need to add a lot of zero pairs. We're going to need to add 7 zero pairs and hope our board is big enough for all of them. 7 zero pairs. Again, our board amazingly still has value of only negative 3, but we also have our 7 black chips that we can take away. So when we start taking away our positive 7 from our board, we are going to be left with 10 red chips. So that means negative 3 minus positive 7 leaves me with a value of negative 10. Let's look at how we would illustrate out a few more subtraction problems using chipboards. Instead of using chips, we're going to use positive signs to stand for positives and negative signs to stand for negatives. Let's start by doing positive 2 minus positive 5. Well, I'm going to start by putting my 2 positives on the board. In order to take away positive 5, I'm going to need to add 3 zero pairs to the board. By adding my zero pairs, I keep the board valued at positive 2, but I also give 5 positive chips that I can take away. Taking away my 5 positive chips, I'm left with my 3 negative chips. So positive 2 minus positive 5 leaves me with negative 3. On our next problem, we're going to start with negative 7. From that, I'm going to need to take away positive 4. This means I'm going to need to add 4 zero pairs to the board. This way, my board can keep a value of negative 7, but yet I'm going to have 4 positive chips to take take away. When I take away my 4 positive chips, I'm left with just my negatives. So -7 minus +4 leaves me with -11. On our next problem, we're going to start with +9. I need to take away +1. In order to do this, I need to add 1 0 pair to the board. This will give me a negative to take away, but it'll also keep the value of my board at +9. When I take away my 1 negative chip, I'm left with all my positive chips. So +9 minus -1 leaves me with a total of +10. In my last problem, I'm going to start with -6. We need to take away -8. This means I need to add 2 0 pairs. This way, the board will keep a value of -6, but yet it'll give me 8 negatives to take away. When I take away my 8 negatives, that leaves me with only my 2 positive chips. So -6 minus -8 is going to leave me with +2.